Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Editor-in-Chief at Automation World, and the question we'll be answering in this episode is, what is high-performance HMI? And joining me to answer this question is Travis Cox with Inductive Automation, which makes the Ignition software development environment that can be used for HMI, SCADA, MES, alarming, reporting, and industrial Internet of Things applications. So thanks for joining me, Travis.
Thanks for having me, David.
All right. So, let's get right to the reader question. I guess first off, they were asking what is high performance HMI and it's about its uses. But let's just start, what's meant by the term high performance when it comes to HMI screens?
Yeah, the principle based or behind high performance HMIs is really to utilize designs and displays that help the viewer make the best decision in the shortest amount of time. Right. So with interacting with the HMI, the idea is that we want the HMI to tell you what's going on and tell you about issues without having to have a lot of background knowledge and domain expertise. Right. Especially if you bring on new people, new operators are coming in. Sometimes you spend hours and hours, if not days and days, on just training on how the HMI works. Well, the idea behind this of these principles help them do their job a lot faster.
And what's the big difference then, if it's so much easier to understand and comprehend even for people without a lot of experience, as you mentioned, what are the big differences between a high performance HMI screen graphics and the more standard ones that we've seen for years and years now?
Yeah, I mean, so there's quite a few differences, and I know there's a lot of people that are pretty not to say against, but that are not that are hesitant to kind of go to the high performance HMI principles. Mm-hmm. But they kind of like to stay with the more classic traditional representations. I mean, a lot of the classic ones, it's a literal visualization representation of the process, right? You're seeing exactly how it's laid out, and you get a lot of detail on the screens. A lot of information you have to kind of digest, and there's a lot of colors, a lot going on. It's because we want to represent the process the best way we possibly can. Mm-hmm. Well, with high performance HMIs, it's really they look a lot more simplistic, right? And they're typically using grayscale rather than traditional graphics and bright colors. And conceptually, this operates under the idea of visually contrasting critical and non-critical states. So that way, when something goes wrong, a high performance HMI will quickly guide the user to the source of the problem. Just at a glance, for example, if we had a real grayscale screen, at a glance, if I saw red, that's going to signify that there's an issue, right? If there's red or orange or yellow, especially if there's not only color, but there's multiple redundant coatings, if there's symbols and things that go along with that, helps us understand where those issues are really coming from. Plus, it's all about adding more context to data, and that's really important, right? We want to be able to look at the screen and be able to understand the data that's being presented in the fastest way possible. And I always like to use the example, if you go to the doctor and you get, they do some, blood work on you, and you get the results back, and they just give you a bunch of numbers, and numbers are just all the same color. How would you know without having to go look up each of those numbers? What's the normal range of that number? Am I good? Am I bad? All that kind of stuff, right? And so we want to be able to apply, these principles to an HMI so that instead of just getting back numbers, I get back, for example, a range, and I can see an indication in the middle of that range. Hey, that I'm in the accepted range, or no, I'm outside of it, and now it's colorized. That's a number that I should be looking out for, right? And so high performance HMIs do the same thing. If I have a set point out there, if there's, for example, I have a tank and there's a level on that tank, I want to know, is that within the right set point? Is it too high or too low? And if I have a little, what they call a moving analog indicator, I can quickly see if that's in the accepted range or not, just by seeing that it's inside of it, right? And if it's out, I get a color, some representation. So it's not only about providing, making it easier to understand what's going on, but providing that context, making it so that people don't have to do a lot of thinking, right? We want to the human brain's really, really good at actually finding out all these like visually seeing these little like digesting that information. We want to be able to help it out. Let us do his job really, really quickly.
So I like the examples you gave there with the lab report information from your doctor and such. Is this, and this is kind of getting back to your point about highlighting the criticality of some information versus others. Would you say this is kind of part of an idea or a concept around HMI to make it not a screen that you're necessarily have to look at all the time and be focused on, but something that you can glance at periodically, and if there's anything trending out of the normative range, that it's going to show immediately? So is this to kind of open up the field of view for operators? Is that kind of the idea behind it, or is it from something else?
No, exactly. I mean, you look at it, a lot of our systems have a local display next to it, right? So we can kind of go over to it and take a look at it. But you don't want to park somebody in front of that display all the time, watching it like really intently. Okay, am I going to have problems? You want them to be able to do their job most effectively. And so the idea of having a screen that even if they're further back, they can look at it and get a sense if things are okay or if it's not, right? And if it's not, they can kind of go in and get a lot more detail about, going a little closer to see exactly what part of the process and really understand that a lot faster. So absolutely. And a lot of this kind of came from, I mean, you think about it, we started getting digital displays, right? And we had to then put our process on digital display. Before that, it was very much in a control room. You had lights and indicators and buttons and all the physical things, right? Now we have a digital display, and we said, hey, all right, engineers, your job, now let's go put your process on that digital display. And it's like, well, how do we do that the most effectively? We didn't really give people a set of tools or guides on how to do that effectively. And that's really what high-performance HMI is all about doing, is giving these tools and guides to help them display it in the best way possible. So yeah, absolutely. And you get to critical processes, a lot like if you look at in petrochemical, or if you're doing nuclear reactors and you're monitoring that, you're going to need these principles because there's just so much data and you got to make sense of that data very quickly.
So, do you know where this idea of high performance HMI idea originated from? And was there a certain event that started it, or is it from a group of people? Do you know anything about the history of this?
So I don't know the exact history. I know that, there's been a couple of decades where engineers have had to kind of think about how their displays and how they're going to provide that information the best way possible, right, to their operators. And especially for these, like I said, critical processes like nuclear reactors and petrochemical, they had to kind of do that faster, right, because they had a need for that. So I don't know exactly who started a trend, but it was just engineers and their kind of thought process and applying some of these rules and working with, some UI people to help figure out, especially even psychologists, right, to figure out how do we do this, the best way. So I think that's sort of how it kind of came about. But I think really what I think stemmed the growth of this a lot was the High Performance HMI Handbook. And we talked a lot about that by Bill Holyfield and Eddie Habibi. That book, it's on Amazon. It's a great use. I think that came out in 2008. It's a great example of putting all of the guidelines in an easy form to digest. And I think from there, a lot more people started to become more receptive to it. And products like us, as a vendor, we really saw the value, and so we made sure all these techniques are easy to do in the product. And so the more that we did that, the more that people could take advantage of it, right? Rather than having to do all of it on their own, they're given more tools to do it most effectively.
So it was you would say it was pretty much an organic process coming out of industry. It wasn't like any one technology supplier or another who started it. It was more of an organic process. Is that a fair characterization?
Yes, that's a fair characterization. Because I've even looked it up to try and see what is the exact origins of it. And it's not really attributed to any one source. It's kind of just something that's kind of came about as engineers have had to deal with this problem set for a while.
So in your experience working with manufacturers of all types who can use Ignition to, as you point out, you can create either the traditional highly graphical HMIs or the high performance HMI screen. What have you seen? What type is most often used in industry?
If you look at new projects that are happening now, the high performance HMI techniques are the ones that people are starting with, are going with, right? Versus the more traditional graphics. I think there's more awareness around this concept these days. It used to be, like there's something to be said about pretty graphics, right? It looks really good, especially if you have some 3D animation on there. It looks really cool. It's a great process, and it makes it look like you put a lot of work into the interface, right? And especially executive folks think like that's really cool, right? It looks really good, but ultimately it didn't do its job effectively. It's the high performance HMIs that really allow the operators to do their job the best way. So yeah, it may not be as visually appealing, but it's proven in terms of being able to save time and to be faster and provide more context, right? There's tons of data points out there that prove that. And so now with that awareness, I think it's kind of a no-brainer for people to start with that, or at least adapt it to their own, how they want to do it, right? Nobody has to take, not every system is going to be exactly the same in terms of the techniques they use. But I think if you develop some guidelines for yourself that works really well, that you get value out of, I see a lot of projects going that way.
For those manufacturers that aren't using high performance HMIs, do you find that they don't use it, based on a specific preference for the more colorful HMI graphics, or is it just, here's what we have, this is what we're used to, we're not going to reinvent the wheel? Where does that fall?
I think is definitely more. We just don't want to reinvent the wheel. We put a lot of investment already into the existing screens and infrastructure we have. Even if they use new products, they're still kind of carrying those principles over, right? They've done a lot of training to their engineers or their operators. And, obviously, if we change that up, there's going to be some retraining that's got to happen, right? There's going to be some investment into it. It's not just an acceptance of the screen. It's kind of a culture change, right? We're doing this because it's going to give us XYZ return, right? They need to be able to explain that to everybody and kind of get that through. I think it just looks like a pretty big uphill battle for some, and they'd rather just not disrupt that, right? Just kind of keep where they're going. Things are working all right. I've seen recently a more increase, right, in adoption, because look, we're bringing on a new generation of engineers into these facilities, and we have to be able to train them, and they're used to getting things on their phones and tablets and all of that. And so there's kind of this new wave, and we're redesigning systems anyway, so we might as well adopt better principles when doing that. So for a lot of them, they're doing that, but there's still some classic holdouts that we got this, it works, why change it, if it works.
Yeah, I wondered myself with this move to so much of the mobile HMI use that's come up with Perspective and across the board over the past several years now, if that was going to facilitate a move towards more high performance HMI use. And as you noted, with the newer, at least with the newer installations, that does seem to be the case with
absolutely.
that.
Yeah, absolutely. And the interfaces are just they're more streamlined, right? They're it's like I said, the high performance graphics, if you look at a lot of even just artwork and or apps that we use in our personal lives, right, they're very kind of clean, right, simple interfaces. And the high performance HMI techniques are that. It's all about keeping it clean and simple, and using not like crazy 3D graphics, things like that. Just so that way it's very easy for people to use it. And the user interfaces and user experiences these days, there's a lot of focus. And when you do mobile design, you have to, right? You have to think about that. So it just lends itself so well to this kind of design.
Okay. So for those who are using the more traditional, the highly graphical HMI, is it complicated or expensive to switch over to high performance HMI?
No, it's not. It's not complicated or expensive. I mean, most products have support for these. I mean, really, we're talking about colors. Being able to kind of look at the, what your color methodologies are. You're looking at, certain kinds of components. Like there are the concepts in high performance HMI, like sparkline charts, which are just the axis-less charts, kind of show the trend of values. So rather than showing current value of the tank, I show a trend of the last couple hours to see how it's trending. Is it going up? Is it going down? We get more context by looking at the trend, right? And along with having the current value, things like that, moving at analog indicator. And so a lot of these products out there have support for this. So it's, if it didn't, of course, you're going to have to upgrade to something that would have it, right? So there might be an expense to that. But I think the return on it is so big that it can easily outweigh that expense. In terms of effort in being complicated, it's not, right? We're just basically taking the existing, process we have and sort of and rethinking it in this way. And I mean, you'll spend definitely some time in that design phase, but to implement it, once you build out a couple of templates, you can do this pretty quickly, right? So I don't think it's about, again, it's just about the acceptance. I think once you say, okay, we're going to do this, here's where we're going to build our standard, then it's about going and implementing that, right? Making it happen.
One of the things that made me start thinking about this in advance of this podcast about how high performance HMI graphics and the use of those are becoming a little more ubiquitous. And this is probably not the greatest example, but I couldn't help mention it. But I saw on the side of a sake can, they had a Spiderplot, and it was basically the sweetness versus dryness, the alcohol content versus others. It was like 5 points in the Spiderplot. Yeah. It's like, okay, this is getting pretty common. They're putting it on the side of a sake can. Yeah. This is not, this is something that I would just expect to see on an HMI or another type of engineering screen. But here we go. This might be becoming more and more common. Absolutely.
Yeah, the Spiderplots or radar charts, they allow you to provide a lot of different set points in an easy, digestible way, right? Because the idea is that if they're all in the right range, you'll draw a perfect circle, right? You kind of see that. And if anything's outside of that, you get a sense of, there's something going out, right? Like it's so, yeah. I mean, these
and in sake, it might be what you're looking for, the sweetness or the dryness being outside the norm.
Yeah, exactly. I mean, it's all about, being able to, again, just help the eye see the data in a faster way. It's I love the techniques. I think they're so useful.
So I just have one last question for you, Travis. And I think in the course of our conversation, you've kind of answered it and you kind of did a little there, but just to kind of wrap up our discussion here, though there's obvious user preferences for the different HMI graphic types as we've been discussing. What's your preference based on what you've seen firsthand from an operational effectiveness point of view?
I definitely think high performance HMI is more effective. I mean, that's no question here from everything we've talked about so far. No. But it's not just from in terms of effectiveness, it's not just being able to quickly diagnose issues, right? Or to be able to get more context. Those are important, but we got to consider things like color blindness with HMIs these days, right? And these techniques they already have that kind of baked in, right? We're not talking about green and red and yellow and orange. We're talking about, very muted if things are okay. And then there's changes if it's not, right? So it's easier for people. You don't have to worry so much about things like that. Things that, not everybody's thinking about. No engineer who's building a system is thinking, oh my gosh, I got to do this. I got to build it for color blindness and this and that, right? It's a lot to think about. But these techniques kind of have it's like a benefit of it, right? So definitely from the people and the companies that we've talked to who use this and the operators who use it on a daily basis, they're very they're very happy with the result that they get, right? Because it helps them do their job better. Whenever we can do that, they can focus on what their real job is. It's not babying an HMI. Their real job is running the process, and the more you can help them with that, the better.
Well, thanks again for joining me for this podcast, Travis. And, thanks, of course, to all our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.